we're going to look at antiderivatives in kinematics. Now, the Victorian syllabus specifies finding distance travelled in a straight line. So the particular problem we're going to have a look at is a particle moves in a straight line from its initial position at the origin. At time t greater than 0, the velocity is given by v of t is 40, 1 minus e minus t over 4. So what we're going to look at is find the position x at time t equals 3 and find the distance travelled in the interval from t equals 3 to t equals 6 and show that on the graph. And write the answers correct in 2 decimal places. All right, so let's have a look at this. The definition of velocity is the rate of change in position. So v of t is dx to t. So if I'm going in the opposite direction, if I've got the velocity and I want position, to find x of t, I need to find the antiderivative of v of t. Okay, so I'll do this in the calculator application. So I want to find the value of x, the position, at t equals 3, and I've already entered function v of t, and I've used the assign, the dot dot equal, which is the same as the time. Okay, so I'm going to have to anti-differentiate in going from velocity v to position x. So I'll put in my antiderivative template, shift and plus, saves you a lot of time. Now, because I started at the origin, at time t equals 0, my position was 0. So in fact, I can integrate from 0, and I tab to the other terminal, from 0, from time equals 0 to time equals 3, tab of v of t, tab t. And I get a rather ugly looking answer because it says to give the answer correct 2 decimal places. So another little trick is if you go to the menu, if you go to the catalogue and you press R and you scroll down, you'll eventually find a command called round, and round allows you to round to a given number of decimal places. So round the answer, so quickest way of getting your one way is control negative, which is the answer, then comma, the number of decimal places, 2 decimal places. And it gives you the answer, so it's 35.58, correct 2 decimal places. Of course, the other thing I could have done, I could also have done control enter, but it would not have rounded to 2 decimal places. It will round to the number that you'd set your calculator settings. Okay, so something else I could have done, which we looked at in the previous activity, is I could have found the value of c, so solve for c. I'm not going to do it again. We did it in the previous activity. And once you know the value of c, which is negative 160, then of course inputted x of 3, and you get exactly the same answer. Once again, I could round the answer to 2 decimal places, comma 2, and you get the same answer. Now let's look at the distance travelled from t equals 3 to t equals 6. Now, you should be familiar with the fundamental theorem of calculus, which essentially says that if capital F is an antiderivative of a continuous function, then the integral from a to b of f of x dx is the antiderivative at b minus the antiderivative at a. So the same thing can be applied to kinematics, and displacement is the antiderivative of the velocity at time 2 minus the antiderivative of velocity at time 1. So let's have a look at this graphically this time. So I've already graphed my velocity function. Of course, I've had to use x as the variable instead of t. And this time I want to graphically get the area. So I can go Menu, then Analyze Graph, 6, and number 7 is integral. So I select 7, and which graph? I've got 2 graphs there, so point to the graph you want. Lower bound. Now, the lower bound, I want to go from 3 to 6. So all you need to do is just hit the number 3. And as soon as you hit the number 3, it appears in a text box. You just press Enter, and it's locked it in 3. Now, the upper bound, so I want to go from 3 to 6, so I just press the 6 key. It appears in the text box, Enter, and I get my area, 80.1. Now, if I want to show more decimal places, the quickest way of doing it is you just touch the number and then just press the plus key. So as you press the plus key, more decimal places will appear. If you press the minus key, you can see fewer decimal places. So that's another neat trick when you're looking at values graphically. Okay, now I could have done exactly the same thing. Now here what I'll do is Control Menu at the point, coordinates and equations, and I'll do the same for this one. Control Menu, coordinates and equations. Now I can now change these values. So if you want to change a value, you can just hover over it, press Enter, Enter, and it makes it editable. So this time I want to go all the way to 0. And so I can see that in the first 6 seconds, from time 0 to time 6, that's about 115.7 is the distance. And of course I can change this, and I can see the distance after a certain number of seconds from the beginning, or I can change this other value and I can find the distance between 2 points. So this is a very good illustration of the fundamental theorem of calculus, as well as an application of calculus to kinematics, velocity and displacement.